Let's solve a problem involving vector addition. We have three displacement vectors that we need to add together to find their resultant. Here are our three vectors. Vector 1 is 24 meters at 36 degrees north of east, vector 2 is 18 meters at 37 degrees east of north, and vector 3 is 26 meters at 33 degrees west of south. To find the resultant, we'll use the component method. We'll break each vector into its horizontal and vertical components, then add those components separately. Let's start with vector 1. For a vector at 36 degrees north of east, the x component is 24 times cosine of 36 degrees, which is 19.41 meters. The y component is 24 times sine of 36 degrees, which is 14.09 meters. For vector 2, at 37 degrees east of north, the x component is 18 times sine of 37 degrees, which is 10.81 meters. The y component is 18 times cosine of 37 degrees, which is 14.37 meters. And for vector 3, at 33 degrees west of south, the x component is negative 26 times sine of 33 degrees, which is negative 18.89 meters. The y component is negative 26 times cosine of 33 degrees, which is negative 20.41 meters. Now let's add all the components. The sum of the x components is 19.4. 1 plus 10.8, 1 minus 18.89, which equals 11.33 meters. The sum of the y components is 14.09 plus 14.37 minus 20.41, which equals 8.05 meters. To find the magnitude of the resultant, we use the Pythagorean theorem. The square root of 11.33 squared plus 8.05 squared. This gives us 11.32 meters. For the direction, we use the inverse tangent of y over x components. The inverse tangent of 8.05 over 11.33, which gives us 35.35 degrees north of east. Therefore, the resultant displacement is 11.32 meters at 35.35 degrees north of east.